Welcome to this tutorial. We'll walk you through the LoRaWAN settings for Milesight sensors using the Milesight ToolBox app. In this video, we take VS341 as an example. Just a quick reminder, Milesight keeps things simple for you. Most LoRaWAN settings can be confirmed when you place your order, and we'll pre-configure them. So when you receive the sensor, there's no need to adjust any LoRa parameters. Just add it to your gateway or network server, and it will connect. Now, let's walk through the settings together. Access the device via NFC or Bluetooth, depending on which method is supported. Once the device is successfully read, go to Settings, Network Module. You'll first see Device EUI. This is your sensor's unique ID. You'll usually need to enter this when adding the device to the network server, so the network server can identify it. The app EUI, also called Join EUI, is a key identifier used during the OTA join process. It tells the LoRaWAN network which join server should handle the device's join request. The application port is used for sending uplink data and receiving downlink commands. It's usually fine to leave it as 85, only change it if your network server requires a different port. LoRaWAN versions 1.0.2 and 1.0.3 define how devices, gateways, and network servers communicate. Most Milesight sensors support both versions. Choose the one that matches your network server. Next, select the work mode that best fits your sensor and application. This affects the timing of sensor data transmission and should be consistent with the configuration on the network server. Confirm mode is important for avoiding data loss. When enabled, the device will retransmit the data once again if it doesn't receive a confirmed response from the network server. Join type determines how end devices are activated to join the LoRa network. We recommend OTA as the default mode. If you choose OTA, you will need to enter the application key. This is the root key provided by your network server. And only OTA supports rejoin mode, which helps validate connectivity. The device will send a specific number of link check REQ MAC packets to the network server, either every reporting interval or every double interval, depending on whether the interval is less than 30 minutes. The number set here is the max consecutive unacknowledged responses. When reached, the device attempts to rejoin. Milesight devices support ABP2 if needed. You will see three fields: device address, network session key, and application session key. Please ensure these three fields match on both the device and NS sides. Then select the supported frequency and enable the channels to match the settings of your LoRaWAN gateway and network server. ADR mode enables the network server to adjust the spreading factor, bandwidth, and transmit power to optimize data rate, airtime, and power consumption in the network. But if ADR mode is disabled, the device will send uplink data using the set spreading factor parameter. The higher the spreading factor, the longer the transmission distance, the slower the transmission speed, and the higher the power consumption. TX power, transmit power, refers to the strength of the outgoing signal transmitted by the device. This is defined by LoRa Alliance. RX2 data rate to receive downlinks or send D2D commands. RX2 frequency to receive downlinks or send D2D commands. Unit, Hertz. This tutorial and Milesight's default LoRa settings are designed for most applications, allowing your device to join the network easily and smoothly. If you encounter specific issues due to unexpected environmental conditions, please contact Milesight support for assistance.